Hi there, welcome back to this channel. In this video, we are going to talk about projectiles quickly. Now, okay, not quickly though, but if you are taking O levels or advanced level courses on projectiles, this video is for you. I'm going to go from the scratch so that you can understand as much as possible and we'll advance. But keep in mind, like we always do, we are going to be having derivations, but in this video, I'm going to show you the way to use those formulas as we solve questions. A-level questions that are going to assist us in understanding the use of the formulas. Okay, so I'm going to practically show you a lot of the different types of projectile primarily that we have. Is that okay? So let's get into the video. Now, what is a projectile? So basically, a projectile is any object. So any object that is launched, any object launched in space, okay? Launched in space and is allowed to move freely under the influence of gravity. Freely under gravity. So what that means is that the only acceleration that the body enjoys is acceleration due to gravity. And I will show you how, okay? So it is motion in two dimensions. It is motion in two dimensions. Why is it so? Now you have seen that, we have seen objects that translate in one direction, one dimension, like just the x-plane. And we have also seen objects that translate in just the y-plane, okay? So what that means is this: if I throw this object up, for example, now what you will see, of course, you are going to see it twisting and turning. For example, you can throw something up, you see that that thing will twist and turn even as it goes up and down. Now, in this case, we are particular about just the up and down motion because the rotational dynamics also has something to do in the overall motion of this body. But if we were to look at this body as a point mass, we will know that this object can only, if it were a point mass, in which case this is what we are considering it as a point mass that can only translate with no significant rotation such that the dynamics is affected. We're only looking at this body as it translates upward and downward or rightward and leftward, in which direction as your frame of reference might be. So I am saying that if I throw this object up, I'm looking at it as just going up and down. The twist and turns or yodeling do not affect the motion. Okay? So now, when I throw this object up, it's going to move in one direction. It moves up and down. That is vertical translational motion. If I throw this object in this direction, it will move just like this, straightward. And it will continue, if not for the effect of if not for other quantities like air resistance, gravitational force, etc. We assume that it should continue with that velocity forever in an ideal case. Is that clear? Now, but in the case of a projectile, when we launch this object, it will fall, it will go up, it will translate upward and rightward. For example, if I throw it from here, look at it now. If I throw this object, what it did was that it translated upward and rightward. So the motion of that object can be viewed in these, as shown in this graph here. So like this. So what this object did, let me make it bigger. Let me make it bigger. So what this object did, as I threw it, was to move from here. Let's say it were a ball, for example. If I kick it, it's going to move like this. So it is going in vertical direction, as the same time it is going in the horizontal direction. So that's why we call it motion in two dimensions. All right, now, make sure you are following me. Whether you have understood this before or not, this video is still going to help you. Just stick with me till the end. I know it's going to be a bit long. All right, now I have, so that is the case for a projectile. That's what a projectile is primarily. Now this path that it takes, the path taken by a projectile is called the trajectory of the projectile. Is called trajectory of the projectile. Now, I'm going to, by equation, prove to you that the path taken by a projectile is parabolic. We can prove it by equation, and I'm going to show you how. Now listen, let's give some examples of projectiles. Now, what are the examples of projectile? We have an object thrown upward, a stone thrown, for example, a stone thrown at a bird on a tree, at a fruit on a tree. You understand? That is a projectile because that stone is going to go up. Of course, maybe it hits the fruit or not, it's still going to come down. Make sense? Provided it doesn't hang in the tree, okay? Another is a football kicked. A football kicked by a player. So if a player wants to pass, do long pass, do you understand? Provided it's not curling, I don't know how they call that thing. You know, passing the ball in order this thing. You know, you place the ball will go like this and, you know, go to the player. If the player was as skillful as I am, you know, it will land exactly where he wants it to go. So that's another example. Another example is a missile launched. So if I launch a missile launched. So for example, I remember in those days, was it in the 17th century, about 1642 or thereabouts, we were in one war like that. So they launched a missile. Okay, sorry, in those days they had not made missiles, sorry. I forgot the date. I think the date is 1920 to 1928 or thereabout. So they launched a missile at us. That was how I was the one that launched it. I've forgotten. So I was in a fighter jet and, you know, I needed to strike. The enemy was killing our people. They were killing our people rather. I needed to calculate the exact angle at which I would launch that missile and to hit them. And I did my calculation in that fighter jet, launched it, and I was able to subdue the enemy. Do you understand? So, and here I am today to give testimony. But then, I'm also going to teach us the angle of projection of a missile. So don't worry. All those things I'm saying, they are real. They are not, do you understand now? The day I did that thing, I was not surprised because I knew I could do it. Do you understand now? Alright, so a missile launched, a football kicked, and a stone thrown at a fruit. Those are types of projectiles. These are all projectiles, in as much as they are allowed to move freely in space under the influence of gravity, and they translate upward, downward, and forward as they move. Then that is a projectile. Is that clear? Now let's now analyze the properties associated with this motion, or the kinematic properties that we use, including speed, including acceleration, distance, and all of those things that we use to analyze motion. Now look at this body. Now this body is launched at this angle. Now when a body moves in a curvilinear path, I've told you that before, when a body moves, the path is curvilinear, right? How do you spell that? Curvilinear. The path is curvilinear. So when a body moves in a curvilinear path, I've told you that the direction is always tangential. Direction is always what? Direction is always tangential at every point on the curvilinear path. So for this body now, when it's being launched here, it's moving, gets here, gets here, gets here. At each of these points, the direction is tangential to that parabola or to this curvilinear path. Exactly, to this curvilinear path. The direction of this guy is always tangential. That is the direction of its velocity. So if that's the case, then this velocity is neither exactly on y component. You know, this is y-axis and this is x-axis. So this velocity is not exactly on y and it's not exactly on x. Okay, and we cannot work with that yet. So what do? We first resolve this component, this velocity. We first resolve it on y-axis and also resolve it on x-axis so that we'll know their values. But this is the starting velocity, so we'll call it the u, or the initial velocity. Is that clear? So by the time, so it is launched at an angle to the horizontal. Let's call that angle theta. Remember, listen carefully, that I said it is launched at an angle to the horizontal, to this horizontal, because in A-level classes, I'm going to give you a projectile that is launched at an angle to the vertical. That is launched at an angle to the vertical, for example. So if I say this guy is launched at an angle theta to the vertical, so this place, and you want to calculate with the equations we are going to derive here. These equations will be derived with respect to angle launched, projectile launched at an angle that is with respect to the horizontal. That is, the formula that we'll get here, they are pertaining with projectile that is launched at an angle to the horizontal. So to get the angle to the horizontal, if you are giving the angle to the vertical, just do 90 minus theta. You already know that, right? Since this entire place is 90, you already know that. And of course, transformations can happen to your equation as you deem fit based on what we have here. But I'll show you how. So it means that if we are calculating also with respect to this place, which is the vertical, then you just do 90 minus this theta. But now we know that since most of our questions is going to be with respect to the horizontal, then we'll leave it this way. So let's do some calculations. Now you see this, some derivations rather. You see this u is on this axis, neither on y perfectly or exactly on x. So what we'll do is we'll resolve. To resolve to this point, if we resolve it to this y component, it will be called u sub y, the initial velocity on the y-axis. And if you resolve it to this component, it will be called u sub x. Okay? Now, how do we resolve it to y component? What do we do? This guy is on this line like this. So we bring it here. By bringing it here like this, what are we doing to that angle? So that angle you are seeing there. That angle will be opening more, right? To be opening further. And I've told you times without number. I've said it like 1,321 times. See, I remember the number. That when you open an angle, it is sign. You use open, sign. Then when you close an angle, you use cos, close, cos. I've said it like 1,122 times now. I don't know. So my point now is that to get the y component, the u sub y is going to be u, this u, we resolve the angle here, that is opening, that is sine of theta. Now the u sub x is going to be, by resolving this guy to this angle, to this line here, we are closing the theta, right? We are closing it. So as we close it, becomes u cos theta. Is this clear? You must first get this. You must first get this. So these are the values of the initial velocity. These are values of initial velocities. And it is very important that we get this because it's the initial velocity that we're usually given. All right. Now, what if we want to get the velocity at a particular time? No, let's not deal with that yet. Let's talk about the acceleration of the body. The acceleration. Now, why do we know that this body will accelerate? We know that it's accelerating because velocity of this body is actually changing in one component, but velocity is not changing in the other components. Now, what do I mean? If you have seen my video on vertical acceleration, vertical motion rather, I have told you that if I throw this body up, okay, in fact, with what you are seeing here, if I throw this object up, what do you see? This object will get to a particular height here and then begin to come down. Now, what that means is that as it got to that height, it could not go beyond that height again. So the velocity that is using to move upward, which is u sub y, that velocity in y component has gotten to 0. So if I throw this object up, the reason why it began to come down is that it approached 0 velocity, 0 speed, and then began to drop down again. Now what will happen is that for it to approach 0, it means that the velocity was maximum at the point of projection and reduced gradually until it got to 0. Then of course, if I release, when it began to come down itself again, it means that the velocity started to increase. It won't jump from 0 to the maximum velocity there. It will approach maximum again at the final distance closest to the point of projection again. Is it clear? So it is at the point of projection upward that it has maximum velocity, and that velocity will reduce all the way to zero as it goes up, then go down again, and just before it touches the ground or rests, it will become maximum again. That velocity. Is it clear? So the same way is the same thing is what's happening here. So for this body to begin to come down here, it means that it approaches the y component of the velocity approach zero here. Is that clear? But you see that if we were to analyze this body from here to here, this body did not change velocity. The velocity at this point, let's make sense of that in case you don't understand. If the body started with a velocity of like 20 meters per second here, by the time it got to this place, what happened to it? That 20 meters per second became zero. Then by the time it comes down, just before it strikes the ground again, it approached that same 20 meters per second. So what does that mean? It means that it came from here and got here, came from here with 20 meters per second, got here with 20 meters per second. So it means that this component, this horizontal component of the velocity never changed. Is that clear? So it means that acceleration on x-axis, a sub x is 0. Is that clear? A sub x is what? 0. Why? Because the body did not accelerate on x-axis. But on the y-axis, we know that the velocity kept changing, kept increasing upward, decreasing all the way up, and then increasing all the way down. So we know that a sub y upward, a sub y when the body is moving upward will be what? Since the body is moving upward, is that for gravity or against gravity? That is that in direction of gravitational pull or against? It is against, right? So A will be negative g. While if the body is the a sub y at when the body is moving downward, I hope this place is showing. When the body is moving downward, okay. When the body is moving downward, a sub y will be what? Positive g. And all of these things will impact the formulas that we are going to be deriving. So watch. This is an ideal projectile that we're looking at now, or like the common projectile motion. So if I say what would be the velocity at a particular point in time, now keep in mind that, and let me clean this. Keep in mind that this what would be the velocity at a particular point in time? That's what I want to check now. So velocity at a particular point in time. Velocity v at any point in time for the y component. V sub y at the y component. So you know that it's the v sub y that is changing. Let's say we pick a point here. Let's say we just pick this point. If we pick this point, we know that at this point, we can draw our coordinate system here again, right? At this point, the velocity is now facing that direction, right? The velocity is facing that direction. You will notice that the angle has kind of changed. This one here is the new velocity, so we'll call it v sub y. This one is the new velocity in x-axis, so we'll call it v sub x. But we know v sub x is not changing. V sub x will be the same as u sub x. But either ways, keeping in mind that we have this as our angle, we can make this into vector. When we make this into vector, what do we have? We have what looks like this. This is v sub x. This one we can repeat it here so that we have v sub y here. So in which case, we can resolve vectorially that our velocity, our actual velocity, sorry, that's what we want to do. Our actual velocity at that point, because you know that velocity will be reducing, right? Our actual velocity at that point will be equal to, using Pythagoras theorem, hypotenuse squared is equal to opposite squared plus adjacent squared. So we have v sub y squared plus adjacent is v sub x squared. Is that clear? So if this so v squared rather is equal to v sub y squared, hypotenuse squared equal to opposite squared plus the adjacent squared. V squared, is that clear? So v therefore become the square root of v sub y squared plus v sub x squared. And you may bring this into context because we first need what the value of this will be. What the value of this will be. I'm not going to show you something with this equation and prove how it is, prove to you that it is right. So what will be the v sub y? The v sub y at that particular point. What will be the v sub y? We know it would have reduced, right? So the v sub y, what? You see that this formula is going to prove that it has reduced. First, let's write the equations of motion that we remember, that we're going to be using all the time. We have v equal to u plus at. We have s equal to ut plus half at squared. The equation for horizontal motion now. We also have v squared equals u squared plus 2as. Okay? So if these are the equations, from here, we can bring this one down to find v sub y. V sub y will be u sub y plus, now instead of at now, our a, when the body is, what's the body doing here? It's going upward, right? So if the body is going upward, it will be plus minus g times t. Is that clear? So v sub y becomes, what is u sub y? U sub y is u sine theta, so we have u sine theta minus gt. Is it clear? All right. Now, also, if we want to get the height at a given point, okay, the height at a given distance is very simple. It's the same thing. We're going to use, now here I'm going to use h instead of s. So height at a particular given velocity, which is not up to. So at this point, what is the height above the ground? If you want to check that, you simply use that formula, s equal to uy now, u sub y still times t minus, because we know this is going up, so we have minus 1 over 2 gt squared. Makes sense? So that h is equal to u sine theta t minus half gt squared. So and like that, the transformations will be going and be happening to the our equation as it goes on like that. Okay, so now there's something I was going to also show you. Now, what about the v sub x? What will be v sub x? Now, v sub x, using that same equation, will be equal to u sub x plus, now what is a here? A sub x is what? 0. So since a sub x is 0, so this will be 0. So v sub x will always be what? U sub x. And this validates the fact that we said that what? The velocity is not changing on the x-axis. Is that clear? So that validates it. So v sub x is u sub x. So since u sub x is u cos theta, v sub x is always what? U cos theta. Is that clear? I hope that is clear. All right. Now let's now derive some equations that are pertinent to projectile motion. Now the first equation that we would like to derive, which I've derived times without number for you, is this. But maybe I will just try to change the method that I'm using to derive. I don't know. Let's just see. Let's see if I can alter things here. The first thing we want to know is, what is the total time of flight for this body? What is the time? No, let's first calculate time of flight, then total time of flight. So, actually, when we say time of flight, sometimes we just refer to time taken to reach the maximum height, or sometimes we actually mean the total time of flight. But usually, if you are told to calculate the time taken to reach the maximum height, you'll be given. That is the time taken, so the first thing we want to calculate is the time taken to reach maximum height. Notice that our equations, they have not labeled them, and it's intentional, okay? It is intentional. It's intentional, okay? These are the equations that I will label. So now the first one is the time taken to reach the maximum height. Now, where is the maximum height? Somewhere around here, right? So at this maximum height, what is one thing that is pertinent, that is obtainable? It is the fact that the final velocity there will be 0. Do you remember that? Yes. So if v is going to be 0 at maximum height, at h max, let's call maximum height h max, v will be 0. Then these are our equation here, that v sub y at that point, which is u sine theta minus gt. V sub y will be 0, right? v sub y will be 0. So since v sub y will be 0, then we know that gt can come here. So 0 equal to u sine theta minus gt. So minus gt comes here. So we have gt equal to u sine theta divided both sides by g over g. And then t becomes u sine theta over g. Now this is very simple, okay? Now, but what if we wanted to calculate the total time of flight? Now, the way I usually derive this is just very simple. Since you know that if this body took a particular time to get here, and this place divides the motion into two, then it will take the same amount of time to get down. So what you just do is multiply this equation by 2. Is that clear? When you multiply it by 2, you get the same answer. But let me use another way to derive it here. You know that now, by the time the guy finishes the entire motion, concludes the entire motion, it will come back to a height of 0. Does that make sense? So if it comes back to a height of 0, then our formula h there becomes, you know that h is actually u sine theta t minus half gt squared. Okay, so if this be the case, I didn't even derive the third equation. Is simple. V sub y squared is going to be equal to u sub y squared minus, if the body is going up, 2gh. And is going to be equal to this by the time you calculate. Is that clear? But the point is that you can transform your stores. V sub y will be equal to the square root of u sub y becomes u sine theta, but let's leave it this way, minus 2gh. So it doesn't really change much. All right, now, I was talking about this, that for total time of flight now, total time of flight, or primarily time of flight, keep in mind that usually when they tell you time of flight, they are referring to total time of flight, the entire time it used to fly. But they can tell you to find time of flight. They can tell you to find the time rather taken to reach the maximum height. Exactly. So that will tell you that for a projectile that is starting from here, for example, that is just thrown down like this, the time you calculate will not be total time of flight. It will just be what time of flight. You can use this formula already. So let's now derive a formula for total time of flight. At the completion of the motion, at the completion of that entire motion, h will be 0, right? So h will be 0 because it comes back here. So equal to u sine theta t minus half gt squared. Let's bring this guy here. So half gt squared is equal to u sine theta t. Divide both sides by t here. One t will cancel one t. Is that clear? So that we'll have here, let these two go there. So we'll have gt equal to cross multiply 2 times u sine theta. By the time you cross multiply, this one is under. Think of this as like gt over 2. So when you cross multiply, okay? So you now divide both sides by g here. So by the time you divide both sides, this t is the total time of flight. So we use capital T to represent that. Becomes 2u sine theta over g. So what do you see? How does it differ from this one? You see that it's just these two, and I told you it's the same. Since the time taken to get to this point here is the same as the time you take to come back here, then simply multiply this time taken to get to that highest point by 2. Multiply this guy by 2, you get this equation. Is that clear? So we'll soon start using those equations to form and to solve questions. The next thing I want to calculate is the maximum height reached. The maximum height attained. Okay? So the maximum height attained. Now, what is that going to be? We want to calculate what is the value of this height from the ground or from the point of projection. What's the maximum height attained? Now, when we discuss another type of projectile, that's why you have to listen. When we discuss another type of projectile, this formula will change. Exactly. What will be the maximum height reached? The maximum height reached is going to be given by that formula. Now, I like to use this formula instead. I like to use this formula instead. Is that clear? I'll tell you why. It's easier to use that formula instead. So we know that v sub y squared is equal to u sub y squared minus 2gh. Now, at maximum height, this one will reduce to 0, isn't it? So that's why I said that formula is easier to use. Exactly. So this one becomes 0. So when this one becomes 0, what happens? Here's what happens. Here's what happens. 0 equal to u sub y squared minus 2gh. So let this h come here, but this time is now h max. So it will be 2gh max equal to u sub y squared. Now what is u sub y? Excuse me, please. Okay. So what is u sub y? U sub y is u sine theta. So we have 2gh max equal to u sine theta. That's u sub y, but it's now squared. So we square this also. So by the time we do this, then divide both sides by 2g to get the formula for h max. This cancels this. Our h max would then be equal to, we square u because u is separate and u is a different guy from this guy sine theta. So we square it, becomes u squared. Now this one is sine theta all squared. The way we write it is sine squared theta. Sine squared theta. What I'm telling you is that sine squared theta is the same as sine theta all squared. All squared. The thing is that we don't put this square on this theta. We put it on the function. So we have u squared sine squared theta over 2g. So this will be the formula for maximum height reached. I hope you are keeping up with me. Good. God bless you, God bless you, God bless you. Now, and this formula is of consequence to us. We'll still use it. Is that clear? So just skip in step with me. Now, the next thing I want to calculate is, what is the horizontal distance, maximum horizontal distance reached? Maximum horizontal distance reached, or range covered. We call it range. Is that clear? So what is the horizontal distance covered, or what is the range? It's not going well. So what will be the range now? What will be the range? Now the range is the horizontal distance covered. Horizontal distance covered. Welcome, sir. Welcome. Yes, sir.
Are those people, they still working in night?
No,
They don't come in night?
they came, but they left early. Yes. All right, sir. Yes. So, what is the horizontal distance? Horizontal displacement. Horizontal distance covered is the range. Now, what will be the range here? Now, you know that here, which of the formula can we use now? Which of these formulas? Which of these formulas? We know that it's very simple. It's very simple. You know that the range covered. Watch this. You know that the range covered from S equal to UT plus half AT squared. Now, which S would this be? The distance. Which distance is this? Let's call it range R, horizontal distance. It's going to be equal to UT. Which U would this be? U cos, UX rather. U sub X. Okay? Keep that in mind. U sub X formula that we got. That's U cos theta. Times T plus. Now, A. Which acceleration would this be? A sub X. Right? T squared. Now, but what is A sub X? Recall that AX is what? 0. So this entire thing has reduced to 0. So our range therefore becomes U sub X times T. Okay? So now what is our range? Now, range, what is u sub x? U sub x is u cos theta. But which time is this? That time is the total time because it's that range we are covering. We are calculating. So it's the total time of flight. And what's our formula for total time of flight? 2u sine theta over g. Is that clear now? Over g like that. So we now multiply this. This will become u times u. We'll have u squared. So range becomes u squared times. Now I want to write this way because of something. We write this like this: 2 cos theta sine theta over g. Now actually here, you see this 2 cos theta sine theta is the same as sine of 2 theta, cosine of 2 theta, sine of 2 theta, I think. Let me show you something. Now in trig, and make sure to see my video on trigonometry. In trig, we have that the sine of A plus B, for example, is going to be the sine of A dot cosine of B plus the sine of B dot cosine or multiplied by cosine of A. So in a case where we now have, what we now have? Two A's. And this formula holds true actually, but I've not proven it here. You should check my video on trig. I've proven it. Sine A plus A, okay, maybe I will link it in the description. It's going to be, let's just copy this, it will look like this: sine the first guy dot the cos of the second guy, which is still A, plus sine of the first guy, which is A, cos the sine of the second, cos of the second guy. Now if you look at this is sine A cos A, sine A cos A. So what do we have? We have 2 sine A cos A's. We have this thing appearing twice. Is that clear? So what does that tell you? A plus A is what? 2A, right? So the sine of 2A is 2 sine A cos A. So when you have 2 cos theta sine theta, like 2 sine A cos A, okay, that way you rearrange it, it's the same, right? Because multiplication is commutative. So we have commutative rather. So we have 2 cos A sine A. 2 cos A sine A is equal to what? Sine of 2A. So I like to transform this using that. That the range therefore becomes u squared sine 2 theta over g. And that is going to be the final answer. This is going to be the range. But when will the range be maximum? When will the range be maximum? When do we experience maximum range? Now remember this formula, that is the velocity at a given height. I'm going to prove, now I'm going to resolve this to be able to show you the actual formula. So but let's hold this for now. Now it will make a lot of, it will soon start making a lot of sense by the time we solve questions, okay? By the time we begin to apply these formulas. Just now, one of the reasons why derivation of this formula is necessary is because it helps you to understand not just where the formula comes from, but why and how to apply them, why we need to apply them, when we need to apply them, and how we need to apply them. Is that clear? So now, when will we have or experience maximum range? Now, what does this mean? That is, when can I throw an object and the object will have the longest range given a particular velocity, because the velocity actually impacts it too. When can I have, at what angle can I project an object that it will have maximum range? Now when will sine of 2 theta have a maximum value? The maximum value of sine graph is what? Sine graph looks sinusoidal. Sinusoidal. So it looks like this. The maximum period, the maximum amplitude, I mean its amplitude is plus 1 and what? Minus 1. So it's when we have what? Plus 1. When do we have plus 1? If this cycle is 360 degrees, here is 180 degrees. So what point is this? Half of that, that's what? 90 degrees. So it is at 90 degrees and at what? 270 degrees. But here we cannot have 270 degrees. So we are dealing with what? 90 degrees. So when do we have 90 degrees? When can this thing turn to 90 degrees? It is when theta is 45 gram naught. Is that clear? So if theta is 45 gram naught, maximum range is achieved at theta equals 45 gram naught. Because if that be the case, our range max becomes u squared sine of 2 into bracket 45 over g, in which case range mass becomes u squared sine of 90. And what is sine of 90 according to what I just showed you? Is plus 1. Is that clear? So over g. So, and this becomes u squared, 90 becomes 1 over g. So this is the formula for our maximum range. Now, keep in mind though, that other thing I said, that 270 degrees, is going to give you like the minimum range, but we cannot have minimum range because we don't project objects like this, right? So that's why it is going to be just 90 degrees. All right. So now, I want you to write all of this down. Let me now show you how we can get the range and the velocity at a given angle. Okay? The velocity at a given angle. And of course, we can even take the ratio of the maximum height to the range covered. The ratio of the maximum height to the range. What's the maximum height here? Is this? We'll take the ratio to the range. Maximum height over range. What does that become? That becomes u squared sine squared theta over 2g divided by range. And range is this. So if you divide it by that, it will be times g over, it will invert, right? G over u squared sine 2 theta. This takes care of this. And you have, now this is sine 2 theta. Not sine theta. This is sine 2 theta. U takes care of u. So the ratio of maximum height to range is sine squared theta over sine 2 theta. We'll have to do more trig here. Now I just wanted to show you some things, okay? You know that this becomes sine theta. You know this one means sine theta times sine theta. And this sine 2 theta is coming from 2 cos theta sine theta. So we have 2 cos theta sine theta. So this can take care of this so that we have sine over cos. So we have that the ratio is going to be sine over cos. And what is sine over cos? Tangent, right? So that becomes 1 over 2 tan of theta. That's the ratio of maximum height to maximum range. So of course, if it's now maximum range to maximum, if it's now range to maximum height, then this will reverse. It will be 2 cot theta because inverse of tan is cot. So, but of course, that's just it. That's just it. That's the ratio. That's the ratio. And it is also useful because you might be told to find the ratio of how far the thing has, how high the thing traveled to how far it traveled. Okay, but let me now show you the velocity at a given time. What if we are told to get the velocity at a given time? How do we calculate that? At a given height, not at a given time. Velocity at a given height. Now, one of what I want to use this equation to prove is that it will validate the equation that we generated for vertical motion. If you remember, we generated an equation for velocity at a given height, right? So this equation can be used to generate it. Remember we said that the velocity at a given height is going to be the square root of v sub y squared plus v sub x squared at the beginning there. Alright. So now let's start using this. Let's start analyzing this. Remember what v sub y squared is. What is v sub y squared? V sub y initially, recall the following first. Recall that v sub y was given to be u sub y squared using this formula. That was what I used the other time. Uy squared minus 2gh, right? Okay? So if that's the case, then use of y squared minus 2gh, then plus, that's, so this v squared y. We can use this formula directly. Since look at it. Since this is v squared and this is v squared y, v sub y squared, so we can use this formula directly. We generated this before, right? So if that's the case, what about the v sub x component? Is also u sub x component, because we said it's not changing. So if that be the case, then this formula translates to v sub y squared will be equal to u squared sine squared theta minus 2gh. Is this clear? Because u sub y squared gives you this. And this one will translate to u squared cos squared theta. It doesn't change because u sub x is u cos theta. So when you square it, it will be u squared cos squared theta. Let's now impute this into the equation. So that velocity at a given height will give us this v sub y squared plus, this, because v sub y squared is all of this. So u squared sine squared theta minus 2gh, then plus we could change this to plus 2, because we could be looking at it as whether it is coming down or going up. Is that clear? But the truth is, it probably doesn't impact it. It doesn't affect it. So let's see, work with it. Let's see if it. I just want to work around an equation here. Now, minus 2gh plus v sub x squared. What is v sub x squared? U squared cos squared theta. Okay? So if that be the case, let this one come here. If it goes there, v becomes the square root of u squared sine squared theta plus u squared cos squared theta minus 2gh. If that be the case, then you know that u squared is common. So v equal to the square root of u squared is common between sine squared theta plus cos squared theta minus 2gh. Now let me show you something. Watch this. Now in my Pythagoras theorem, I have that hypotenuse squared, this hypotenuse, this angle theta, these are opposite, these adjacent. In this equation, we have that opposite squared plus adjacent squared is equal to hypotenuse squared. You know that, right? Or hypotenuse squared equal to opposite squared plus adjacent squared. Now let me show you a manipulate. I just want to manipulate things. I want to say that if I divide through by h squared, for example, let me divide through by h squared. I divide everybody by h squared. So I've not changed anything. You first remember that so, ka, toa. Remember this, right? That sine theta is equal to opposite over hypotenuse. That cosine of theta is adjacent over hypotenuse. That tangent of theta is equal to opposite over adjacent. You should already know this. Is that correct? Since that's the case, this can take care of this to give us 1 here. And here, this becomes O over H, all squared, plus A over H, all squared, is equal to 1. What is O over H? That is sine theta. That is sine theta, all squared, plus A over H, that is cos theta. All squared is equal to 1. So this becomes sine squared theta plus cos squared theta is equal to 1. Now if you don't know how to derive this, I've done justice to it in my trick video, trigonometry video. And do well to subscribe to the channel and see that video. There's even a question I asked in that video so that to help you. So do well to see that video. Now, you see, so sine squared theta plus cos squared theta is what? Is 1. So look at here. Sine squared theta plus cos squared theta is what? Is 1. And this proof holds true. Okay? Now, if that be the case, then our equation transforms to v equal to the square root of u squared times 1 minus 2gh. Is this clear now? Is this clear now? U squared minus 2GH. I think we're even done. Okay, let me see if it proves the equation I was trying to prove. In our vertical motion, we said that V squared will be equal to, for a body going up, U squared minus 2GH. It's exactly the same. Do you see now that this formula does not change for a body going up? Is that clear? So that's just it there. That's just it there. All right, let's go. Let's go now. Let's go. Let's go. Let's go. Now let me now show you what we wanted to find the angle. What we want to find the angle at a given height, or angle at a given time. So we'll do both. Let's do both. Angle at a given height now. What will be the angle of the projectile at a given height? How do we do that? Now, remember that if I have my projectile like this, I pick a height like this, for example. I know that at this height, I have V sub y and I have V sub x, right? So, and this is my direction of V. Now, what will be my angle? How do we find angle of something like this? Our vector diagram, triangular, this thing looks like this, V sub y, V sub x. So, in that case, what we are doing is, we want to take, we have this value and we have this value. We'll take tangent of theta is going to be V sub y, because this angle theta here, that is opposite over adjacent, which is V sub x. If you have seen my video on vector, you should know this. This is how we find an angle or direction of the vector. That will be tan theta equal to this, where theta will be tan inverse of this. So if that be the case, then we know that tan theta will be equal to what? V sub y over V sub x. Now, remember here that is at a given height. So which formula for V sub y are we using? Remember that V sub y squared is equal to U sub y squared minus 2GH, right? So in that case, V sub y will be equal to the square root of this. Y V sub x is U sub x, V sub x squared is equal to U sub x squared. Okay, so this is the formula we're using. So we have that the tangent of theta is going to be V sub y will be the square root of all of this, right? The square root of U sub y squared minus 2GH over. Now keep in mind that this is velocity vector, the actual velocity. This is not y component or x component. So I wanted to say something. Over V sub x is U sub x squared. I mean, if you take square root of both sides here, square cancels square root, so it's still U sub x squared. So this shows you that tan theta is going to be the square root of U squared sine squared theta minus 2GH over U sub x here. What will U sub x be here? It's going to be U cos theta, the same thing. U cos theta. So this is the angle at a given, theta will therefore be the tan inverse, of the square root of U squared sine squared theta minus 2GH over U cos theta. Okay? So that's the case. So that's the formula that we'll need. What we want to find the angle at a given time. At a given time. We want to find the angle at a given time. Now don't worry, we are going to put these equations into work now, but we'll derive just one more after this. Just one more. Now, the reason why I want to derive that one more is because I want to solve two questions or one question on it too. Okay? So angle at a given time, what would it be? It means that we still know that tan theta is V sub y over V sub x, right? Now, this case, we are going to write v sub y in terms of time. Here we wrote v sub y in terms of height. Now we write v sub y in terms of time. So in terms of time, v sub y is from here, u sub y plus or minus gt. If that be the case, then our angle tan theta becomes v sub y, which will be u sine theta minus gt over v sub x does not change, it's still u sub x, u cos theta. So this, okay, now we'll now say theta therefore will be the tan inverse of u sine theta minus gt over u cos theta. Is this clear? Now stick with me because we are still going to do projectile from a height, projectile bomb, when a bomb is launched, okay, bombing by a bombard, the one I told you about, the war that we fought, when I shot that bomb, I will show you how I calculated the bomb. That's why you need to stick till the end of this video. I want to show you how to launch a bomb, you understand, so that those of you that are aspiring to be fighters, you understand, when war breaks out like this, you have learned it from me, do you understand? But in Jesus' name, war will not break out. All right, now let's go to now remember I said that the path that is taken by a projectile is parabolic, right? Now how is it parabolic? Remember first that which equation, which type of equation gives us a parabola? Which type of equation? You remember that it's a quadratic equation that gives us a parabola, right? Quadratic equation. Quadratic equations give us parabola. Let me quickly teach you something. See, remember that if I have x squared plus ax squared plus bx plus c, for example, this is the natural form of a quadratic equation. If I have this, the formula, the kind of parabola I will get will be, now this is how you get it. Is this x squared, is it positive? If it is positive, use this emoji to remember. There are two emojis here. Look at this. There's one that is like this. What is this doing? It's a smile, right? Then look at this other emoji here. What is he doing? This guy is angry, right? Okay. So if this guy is angry, watch. When the guy is smiling, it means x squared is positive. So whenever your x squared is positive, you get an upward facing parabola for your equation. Is it clear? Then, whenever your guy is angry, whenever your guy is negative, like this, for example, if I have an expression that looks like this, c plus bx minus ax squared, for example, equals 0. In this one, x squared is negative, you are going to get an upward facing parabola. Look at it. Upward facing, that's why the guy is sad, because it's negative. The guy is happy because it's positive. Is that clear? So downward facing parabola is what? Downward facing parabola is what? Downward facing parabola is when your x squared is negative. So which one looks like our projectile now? This one, right? Since it's this one that looks like our parabola, what do you expect? You expect the coefficient of x squared here to be what? To be negative. So let me prove that to you. Let's prove that. So follow me. Now it's very simple to prove, so just follow me. Now, you know that, which of these equations are we going to use? So common sense tells us that the equation we will use is the equation that looks quadratic already, which is this, right? This guy looks quadratic already. So we are going to use it. Now, how do we use? Then you ask, can we not use any other equation? No, that's the only equation we can use. I mean, that's the equation that looks quadratic to prove it. But if you look at that equation vividly, it is distance written in terms of time. It is s distance written in terms of t's, times. So we have to change that expression to be distance written in terms of distance. Okay? So for example, we want to write it for x-axis. For x-axis, we will have that when you travel that total distance, we will have that it is only u at x component times t, because we said acceleration will be 0. So this is all we have for x-axis. So for x-axis, the value of that expression for x-axis is what? U cos theta times time. Is that clear? Good. Now, what if when the body travels at y-axis? When the body travels on the y-axis, because the body is traveling both at x and y-axis, so we want to write this y as the displacement, the overall displacement in y-axis. Is that okay? The overall displacement for the entire parabola, rather, in the entire parabolic curve. So, but let's first transform this. This would what? U sub y times t minus, now you can use minus or plus, but we like to use minus. Minus what? Half gt squared. Is this clear? Now, if this is clear, remember, so this is equation 1. Oh, we didn't even name since. Sorry. We didn't label since. Just be labeling your equations, please. Label your equations. Label all your equations because you use them. Now, so x becomes u cos theta t. Since that's what we have there, then t will be equal to x divided by u cos theta. Then you wonder, why did I do this? The reason is, this expression is still written in terms of t. So we want to write it in terms of x, horizontal displacement. So we want to write it in terms of horizontal displacement. We'll substitute for that t. So to substitute for that t, we have y equal to u sub yt minus half gt squared. That's what we have in equation 2. This is equal to equation 3. So anywhere we find t, we'll put this. So y becomes, what is uy first? Uy will become u sine theta. Remember? Times t, which is x over u cos theta. Then minus half g times t again, which is, but it's squared now. U, which is x over u cos theta. Everything squared. Is it clear now? Is it clear now? Is it clear now? Is it clear now? Yes, it's clear now. Are you sure it's clear now? Yes, it is clear. Now from here, what do you have? From here, here's what we have. We'll have that y becomes u sine, let's put x in front. X times u sine theta over u cos theta. Obviously, u will take care of u, right? Then minus gx squared over 2u cos theta, this one squared. So 2u cos theta all squared. So square this, it becomes u squared cos squared theta. Okay? So in that, then we have y equal to x. Now, what is sine theta over cos theta? Sine theta over cos theta is tan theta. Let me quickly show you. You know that cos is equal to opposite over sine is equal to opposite over hypotenuse. And cos is adjacent over hypotenuse. When we put them over each other, that is sine theta over cos theta. When we put them over each other, what do we have? O divided by h times h over a. This takes care of this. It becomes O over a. As opposite over adjacent, which is what? Tan theta. So x becomes x times tan theta. Is that clear? Minus, now looking at this, g x squared over 2u squared cos squared theta. Is this clear? So by the time we write this in terms of what we have, in terms of the parabolic equation, the equation for a parabola, it will become, let's write this first, becomes y equation, y in terms of x, becomes, I've not been putting this because, but this is y in terms of x, is that clear? Becomes x becomes negative g, let me write the coefficient first. Negative becomes, let me change the marker, becomes minus g over 2u squared cos squared theta, all of this times x squared. So this is the coefficient of x squared. What do you see? Negative. Then plus x or tan theta x plus c. C here will be 0. Is that okay? So what do you see? Our x parabola is negative. So if it's negative, remember, it will do what? It will be angry. Right? So that's why this proves that what? So this expression proves that what? That our equation, the path taken by, it proves that a projectile takes a downward parabolic path, parabolic trajectory. So that's what it proves. Is that clear? So now, where do we use all of these equations? Let's now solve questions. Let's solve questions. Okay, so here are 3 questions that for most of our equations can be applied for. In fact, all our equations that I've derived. Okay, I was about cleaning this when I remember that there was a question that we can use to solve it. So we'll start from number 2. Is that okay? Or we'll just keep it somewhere. Let's keep it somewhere so we can start from number 1. Y in terms of x is equal to minus g of x squared over 2u squared cos squared theta plus tan theta x, sorry. So then you ask me, would I need to cram this formula? Yes, you need to cram it because you are the student. Is that clear? You need it to solve questions. I mean, I don't have to tell you that you need to cram them. All the formulas that we have been deriving, you need to cram them. Of course, the purpose of the derivation is if you forget, you can generate it yourself. I remember an exam I was writing in university then. I forgot the formula for Pearson's Pearson's correlation coefficient. I needed to derive it in the instance. So because if you know that formula well, it confuses one sometimes, and I knew how to derive it, so I derived it. So it's necessary. Let's go. Number 1 says that a projectile fired with a velocity this. So our V, we need a calculator. U is what? 40 meters per second. At an angle theta equals 30 granite. With horizontal, with the horizontal. So this is to the horizontal. Okay? So calculate the time of flight. Very simple. T equal to 2u sine theta over g. Now you see, one of the reasons why you need to know the derivation is that one of the things that confuses some students about this is they don't know whether the 2 is down here or is up here. Because with time of flight, maximum height, you see u squared sine squared theta over 2g. So some students are usually confused. So hence, you have to master it. Usually, you get to master it if you have solved a lot of questions on it. What is that? Yes, sir. All right, so let's quickly solve this question. We have that t will equal to 2 times u, which is 40 sine 30 degrees over 10. I brought a calculator. So what is sine 30? Sine 30 is half. So 2t equal to 2 times half of 40 is 20 over 10. Here. So we have 2 times 2 is 4. So the answer is 4 seconds. 4 seconds. Alright, what's the next one there? It says we calculate the maximum range. So remember that the range is given by u squared sine 2 theta over z over g over 2g. U squared sine 2 theta over range is I think it's over g. I think it's over g. So range becomes u squared. That will be 40 squared sine 2 times 30 over 10. Okay, given that we are using g as 10, okay, not 9.8. So 40 squared, that's 1,600 times sine 60 over 10. So this 60 of this, we have 160 times sine 30 is sine 60 is root 3 over 2. Here we have 80. So the answer is 80 root 3. 80 times root 3 over what? 80 times root 3 is 138.56. I have 138.56 meters. That is the range. This one is 4 seconds. Now, the reason why I'm rushing is that we are going to have to continue in another class because this class is to be used. This is a borrowed facility, right? So the next one is the trajectory. The next one is the ratio of range to maximum height. So it means we have to use the two formulas now. Range over maximum height now. Over max height. What formula for range? Range is u squared sine 2. We got it as half times something the other time. Let's just redo it. Over g divided by max height. What is maximum height now? What's formula for maximum height? U squared sine squared theta over 2g. So this becomes u squared sine 2 theta. So sine 2 theta, you know it came from 2 cos theta sine theta over g, right? So divided by u squared sine squared theta over 2g. So this becomes u squared times 2 cos theta sine theta over g times times 2g over u squared sine squared theta. So sine squared theta is like sine theta multiplied by sine theta. So g takes care of g, sine theta takes care of sine theta. Then what we have here is u squared times 2 cos theta times 2, that's 4 cos theta. This is different from what we got before. Over u squared sine theta. This takes care of this. So the answer is 4 cos over sine. Remember that sine 4 times cos theta over sine theta. Remember that 1 over tan theta is cot theta. And 1 over tan theta is this cos theta over sine theta. So it means that our formula becomes 4 cot theta. You want to take chair, right, man? Chair. Charge. You can charge in the hall. You know what? I'm coming. When I finish, I'll help you charge. You can drop your gadget here. I'll soon finish now. This one. No, just drop it on the table. Drop it on the table. Okay. All right. 4 cos theta. So the ratio becomes 4 cotangent of what's our theta is 30. So we do cot theta. Okay, my calculator does not have cot theta, so I'll have 1 divided by tan theta. So that will be 4 times 1 over tan 30. So tan 30 is equal to this. So 1 divided by that. Tan 30 is that. 1 divided by answer is 1.73. So the answer is 4 times 1.73 by 4. The answer is 6.92. So the ratio is 1 ratio 6.92. Okay? So that is that. Now let's go to the second question. The second question says, see, I'm trying to rush. Let me quickly. So that's the formula, please, okay? So it's not half of tan. So it will be 1 over 4 tan. And that one that we did, please. It was a mistake I did in the derivation then. So this one, the trajectory of a projectile launched from the ground is this. So it's given by this equation, y equal to minus 0.025x squared plus 0.5x. So we'll just compare with that equation. So this side is equal to that side. Yes, ma'am. Thank you. So we have tan theta x is equal to this side, right? Because this side is the one that is the coefficient of this guy. So what do we need? Where x and y are coordinates of the projectile on a rectangular system of axes. Now calculate the initial velocity and the angle at which the projectile is launched. So the easiest one to calculate is the angle. So the angle of launch. Now, how do we just relate this guy with this guy because they look alike, right? So tan theta x is equal to 0.5x. X takes care of x. So that tan theta becomes 0.5. So theta becomes tan inverse of 0.5. Now, what is tan inverse of 0.5? Shift tan 0.5. That gives us 26.56. So theta equals to 26.6. Okay, degrees. Okay, so that's the angle of launch. Then the other one says we should calculate the initial velocity. So which of this part of the formula contains initial velocity? This part, right? So we'll compare them again. So let's compare that side. Negative gx squared will look negative gx squared over 2u squared cos squared theta will look exactly like this side. That will be minus 0.025x squared. Are you following? So this takes care of this. Then you can now cross multiply and do your thing. You know that g is 10. G is 10. So we have minus 10 over 2u squared cos squared theta equal to minus this. So minus takes care of minus already. So this can go 0.025. By the time you cross multiply, you have that 2 times this, 25, that is 0.05. So it becomes 10 equal to 0.05 times u squared cos squared theta. So what do you do? Divide both sides by 0.05 here. So this becomes here. U squared cos squared theta becomes 1, 2. So 5 here 200. So equals 200. So you now, what is theta? Theta is already gotten, sorry. So it becomes cos, so u squared will be equal to 200 divided by cos 26.6 all squared. So that u squared becomes, what is cos 26.6? So you square it becomes 0.799, 0.7995. So 200 divided by that answer is going to give you 250. So u squared becomes 250.15. Okay, so square root of that answer, because we take square root of both sides, right? So u becomes square root of that answer is 15.8 meters per second. All right, so that's the answer for that one. Then the third one, the stone is projected at that angle. Theta is 60 degrees, right? To the horizontal, with velocity u being 30 meters per second. Calculate the height, the highest point reached, that's maximum height. Maximum height is u squared, h max is u squared sine squared theta over 2g. So u squared is 30 squared sine theta sine 60 all squared over 2 times 10. Take g to be 10. This becomes 900 times root 3 over 2 all squared over 20. This takes care of this. This becomes 45. So this becomes 45 times root 3 squared is 3, right? Root 3 times root 3. That's root 9, which is 3 over 4. So this becomes 0.75. So 45 times 0.75. 45 times 45 times 0.75 is equal to the maximum height, which is 33.75 meters. That's the answer there. The second one, the range. So to calculate range here, the same formula, u squared sine 2 theta over g, right? So u squared again, 900. You square 30. Sine 2 theta, 2 times 60, that is sine of 120 over 10. This takes care of this. So 90 times sine 120, that will be 0.5. Sine 120 And 0.8 is root 3 over 2, yes, double that. So times 0.866, so times 90 is equal to 77.94 meters. So this is the range that is reached. Then the time taken to reach the maximum height. What will be the time taken to reach maximum height? T here equal to just u sine theta over g, not 2u. So that becomes 30 times sine 60 over g, 10 here, 1 here, 3 times root 3 over 2. That will be sine 60 times 3 is equal to 2.598. So that's like 2.6. So that's approximately 2.6 seconds to reach the maximum height. Then the last one there says we should calculate the height of the stone at the instance that the path taken makes this angle. So what we just use is very simple. It's just this guy. You recall that tan, we're calculating height, right? That tan theta will be what? V sub y over V sub x. So we said this will become the square root of u sub y, which is u sine theta, u squared sine squared theta minus 2gh, so is this h you are looking for, over u cos theta. Okay? So tan 30, what is tan 30? Tan 30 is equal to 0. That, so we have 0.577 equal to the square root. Let's just square both sides. Let's square both sides. Yeah. Square root of u squared. You know where I got this formula from, right? From that other equation there that we used to find angle at a given height. So this is the angle. What is the u? The u is still 30. So 30 squared, 900 times sine squared. Now the new angle is what? 30. The path makes this angle. So sine squared 30 minus 2g, that's 2 times 10h, right? Over u, which is 30, times cos of 30. Okay? So from here, let me clean this side. From here, we would have that. We square both sides. If we square both sides, we'll get on this side square cancel square root, then we'll square this one too. This one will give us, square of this will give us 0.333, so equal to 900 times sine squared that. Now what is sine 30? 0.5. 0.5 squared is 0.25. So we have 900 times 0.25 minus 2 times 10, 20h, over square of 30 is 900 again, times cosine 30 squared, that is root 3 over 2 squared. That will be what? 3 over 4. 3 over 4. So 4 here 1, 4 here, 2 here 450, half of 450, that will be 225. 225 times 3. So we can cross multiply, we'll have 0.33 times 225 times 3 is equal to 900 times this, 25 times 9. Is equal to 225 still, 225 minus 20h. So let this one come here and let all this come here. So we have 20h will be equal to 225 left alone here minus all of this. Now, this will be 225 times 3. 225 times 3 is equal to, then times 0.333 is equal to 224.7 minus 224.775. So 20h is equal to 225 minus 225 minus 224.775. equal to 0.225. Divide both sides by 20. I guess I already made a mistake somewhere. Divide by 20. I think I made a mistake somewhere. 0.1125. But either way, that's still right the answer I got now. But I think I made a mistake somewhere. What you will do is this. Resolve this question. But this is the formula you are using. Is that clear? Because this is the formula that contains at a new angle and a height. Is that clear? So let's so that will be it for this video. No, let's continue to projectile on a cliff. So I'll pause the video now. We'll now change facility. Or I'll resolve it, please. Let me resolve it. Let me see if I can quickly resolve it in the other facility I'm going to. My mic is not on. I said that I'll resolve this question. My mic was not on. I'll resolve this question because the facility was changed, okay? They are using the facility, so I have to come here and I want to resolve that question. So I wrote only the D part. So it says that the stone is projected at this angle. So we are using this formula because we know that we are writing the angle in terms of height. So the formula we use therefore will now become tan theta equal to the formula v sub y, which is the square root of u sub y squared, which is u squared sine squared theta minus 2gh over u cos theta. We saw this formula, right? Now, tan theta, so tan theta, what's this angle theta? Is our angle, the new angle that it makes, right? That's 30 degrees, okay? So equal to the square root of u squared. Now, what is u? The 30 degrees, 30 meters per second, rather. So squared, okay, maybe it's this calculation that got us wrong. Sine squared theta. So sine squared, the theta is, okay, you know this theta is the former, okay, that was our mistake. This theta is the former angle, okay? This new angle, you know that we're writing this in terms of the new angle at a particular height. So this is the former angle it makes. I hope that is clear. This is the former angle with which it was projected. This angle is the new angle that it makes because the formula is theta equal to tan inverse of this. Do you remember? You want to get theta. So this is the new angle and this is the former angle. I think that's our mistake. Okay, minus 2g, that's 10 times h. Okay, so over, the root is for the upper, right? So 30 cos former angle again. Is it clear now? So square both sides. So I don't think we should make any mistake now. Square both sides. What is it? Let me quickly solve this first. So this becomes, let me take the calculator. The tan inverse of The tan of 30, tan 30, that's root 2 over 2 squared is 0.3. You see 0.33. Okay, so we didn't make, okay. Do you know, I thought we made a mistake there. 0.333 equal to, by the time you square this upper part, it's cancel square root. This one becomes 900 times sine 60 is root 3 over 2. Root 3 over 2 squared is 3 over 4. So we have this 3 over 4 or 0.75. 0.75 minus 20h. Is that clear? So divided by 30. Now, if you square this side too, it becomes 30 squared. That's 900 times cos squared. You know you are squaring this too. Like you are squaring this too. So this squared, cos squared 90, the same thing. Cos 60, sorry, cos 60 is cos 60 is 0.5. So 0.5 squared is 0.25. 0.25. All right. So if this be the case, then we cross multiply. Never come and use this to cut this, please. Don't make that mistake, okay? So then we go on by cross multiplying, and we'll have this, 1, 2. So we'll have, so 1 over 4 would have just sorted it. Because 25 times 9. That's 225, yes, that's 225. So we'll have cross multiply. No, let me verify well. 1, 2. So 75 times 9. 75 times 9 is equal to 675. So when you cross multiply, we have 675 minus 28 here is equal to 9 times this, 9 times 25. 225, yes, 225. So which mistake did we make? Times 0.333. Okay, I guess this was different from what we even got. So we now have, so multiply 225 times 0.33. That's 74.925. Okay, this was not what we got before. So 675 minus 20h. So let 20h come here, let this one come here. It becomes 675 minus 74.925 is equal to 20h. So 675 minus answer as 600.075 equal to 20h. So divide by 20, approximately 30. Wow. Because divided by 20, that's 30.00 something. So that's 30. So h becomes 30 meters. So I'm sorry. I think the mistake we made was probably the angle. Maybe we used the same angle the other time. That was the probable mistake. That was the mistake we probably made. Okay. Now, the next thing we want to do, so we have done this. Now the next thing we want to do is, now let's now do projectile on the cliff. We must finish everything about projectile. Is that okay? So, projectile on the cliff now. Projectile on a cliff, okay, or a mountain. Exactly. So what that means is this: if I project, if this is my horizontal floor, and I project something from, let's say this is a mountain, or let's say our mountain is this shape, okay, and I project it like this. Now let me first project before drawing it. I project something like this to come down like this here. So that body comes down, gets to the ground here. Now, and it's projected from the top of something here, like this. Now it could be projected from this height, too. Like it could be projected from this and this thing just gets here. But since we project like this, we'll draw it as though it were to cover this horizontal range. That's the way it helps us to calculate in math. As I'm saying that if this clip is like this and I shoot is like this, and I shoot the missile like this. Now, if I launch the missile like this and it comes from here, we'll draw this, we'll extend it so that it will look like the range is covered horizontally. Is that clear? Now, the problem with this thing is that students don't know that the formula actually changes sometimes. The formula actually changes. Sometimes they don't know. So, what we have to do is let's analyze it. Now, you know that this clip has a height. So, from this place to this place, let's call it the initial height. So, we'll call that H1. Is that clear? We'll call that H1. Then, the height that the guy reaches, that the projectile itself reaches, we'll call it H2. Where are these people? So, the height, so I said this height, let's call it the initial height. So we'll call that H1. Let's call this H1. Now, then the height that this body reaches when you project, this is the maximum height here. So it's going to be from here to here. Let's call this one H2. Is that clear? So from here to here is also the H1. So the dynamics change. So because the maximum height reached by this thing, the maximum height reached, maximum height above the ground now, above ground level is going to be the height of the mountain, of the cliff, plus the maximum height reached. So it's projected with velocity u. So this becomes the maximum height h max will be equal to h1, which is the height of the mountain itself, plus the h2. Because h2 here now is going to be the formula of u squared sine squared theta over g. So plus u squared sine squared theta over g. So this becomes the formula. Now what will be the formula for h1? We already know that h1, well, it depends. Now let's try to, it doesn't really, I'm trying to say that this h1 to go from here downward will just be, you know that if something goes from there downward, we assume that the body is projected from zero velocity. So we use h equal to ut plus half gt squared. Then this one is 0, so h becomes what? Why is it plus? Because it's going down, okay? The body is going down. So it's in direction of acceleration to gravity. So h becomes what? 1 over 2 gt squared. So it means that our formula can become, if we are given the parameters, these parameters, our formula can become, this h max can transform into h1, which is now half gt squared, 1 over 2 gt squared, or gt squared over 2, either way you want to write it, gt squared over 2, because this is now 0, plus u squared sine squared theta over g. Okay? So this is another formula for the h max. Now what we want to calculate total time of flight. Now total time of flight will be, the total time of flight will change also. Total time of flight, or just time of flight. I like to put total time of flight. Now total time of flight or time of flight will basically be the time taken to go from here to here first. Remember that one. So there will be 2 times here. Let's call that one T1. Okay, for the projectile to get here. Then the T2 will be the time taken to go from here to the ground. Is that clear? So that will be our total time of flight. So total time of flight here will be what? T1. What is T1? Time taken to go from here to here. And what's that formula? 2u sine theta over g. Is it clear now? So plus T2. What's T2? Time taken to go from here here. You can easily generate that here. You know that H1 gave us what? H1 gave us, which is the height of the mountain, gave us 1 gt squared over 2, right? Half gt squared. By the time you cross multiply, you have that t squared equal to g 2h over g. Then you take square root of both sides. So t will be equal to square root of 2h over g. So we have t equal to 2u sine theta over g plus the square root of 2h over g. This is another formula. Now here's another formula too. Now watch. Let's parameterize a particular time t3 and call it the time taken to go from the maximum height downward. So t3 is time taken from h max to the ground. If that's the case, then we can say that the total time of flight will be the t1 plus t3, where t1 is still time taken to go. No. Let's call this one t now, because if it's t1 we have already parameterized it to be the one from here to here. So let's call t the time taken from here to here. So the time taken from here to maximum height, t is time to reach h max. So if that's the case, so t becomes what? U sine theta, half of 2u sine theta, right? U sine theta over g. But what will t3 be? T3, what will it be? It will be the time taken from here to this place. And what is here to this place? Here to this place is height 2 plus height 1. Okay? So that will be the time taken to go from height 2 to height 1. Now what's the formula for height 2? Time taken to get to height 2. That is u squared. Time taken to go from here to here will be, let's call h1 plus h2. Let's call it our h max. Is that okay? So if our h max is h1 plus h2, because it's going from here to here, right? Then our time, recall that time is equal to the square root of, I've gotten it now, the square root of this. So t3 will be the square root of 2, which of the h now? This h max, which is h1 plus h2 over g. So the formula, so that depending on what you are given, you can solve the formula either way, solve the question either way. So if that's the case, then our total time of flight, which we parameterize to be t plus t3, will be equal to, what is t? U sine theta over g plus t3. What do we get t3 to be? T3 is square root of that, square root of 2h max or 2h1 plus h2, it hasn't changed, okay, over g. So this is another formula. Is it different? Yes. You see it's different. You see it's different. So it's still t. Then you can go on to do things. You can equate them and see what will come out. Alright, so this is that. Now let's solve one or two questions on this. Let me write a question here. I will not be cleaning the formula because we might need to use it. So let me write a question on the board or two. Now, after writing this question, I discovered that we have not obtained an expression for range. So let me obtain it here. So what will be the total range? The maximum range. Okay? So the horizontal range is going to be, there are two ranges here, from here to here. So from here to here coincides with from here to here. So that formula is going to be u squared sine 2 theta over g plus, the total range is going to be from here, from this place to this place, okay? So that will be the total range. So if that's the total range, we only know for the projectile, we only know from here to here, right? From here to here. So how do we calculate this rest here? It's very simple. The same way as we did that vertical height. You know that vertical height from here, u was 0 here. So For horizontal range, for if you throw an object down like this, let me, quick, let me quickly show you this here. If I throw an object from a height down like this, I just throw it down. Eh? Now the height, the formula you use is for the height is what I gave you there, is what we did here. Okay? So but if you use the same formula, h equal to ut plus 1 over 2 gt squared, you can also use this to calculate the range. How? The range is distance moved from here to here. So when you are moving from here to here, you know that the body has no acceleration due to gravity, right? A is 0. A sub x is 0. Do you remember now? So if that is the case, then this is 0. So h will be equal to u times t. But h will now be x. Is that clear? I think I already did that. But now, keep in mind that this x, this u is u sub x, and this t is the time taken to go from here down. And what's the time taken to go from here down? Is 2h root 2h over g. Is that clear now? Root 2h over g. So our formula x becomes our range for this one from here to here, which will look like from here to here, will become, so more like, let's even write this one like this, that r1 plus r2. Because r1 is the normal formula, u squared sine squared theta for the sine 2 theta rather, for the projectile over g, then plus this one now will be ut. Now u times, what is t? T is root, so u times root 2h over g. So this is another formula. Is it clear now? So that will be the formula we use for the range. So I'll clean here so I can solve the question. So you use this formula for range when a body is thrown from a height down. We are not looking at whether it's covered in small. No, we are not looking at this at all. We are just looking at the height down. Do you understand? We are just throwing an object down. We are not projecting up first. I don't know if you understand. You see that this one is not projecting up first before coming down. No, we are looking at the one that is just thrown down, straight, not straight down, just down without checking from, without projecting first. Exactly now. All right. So let's solve this question now. So this is the formula you use in that case. U times the time taken to fly down. Now, the maximum, so we said so we are giving you projected upward with u equal to 80 meters per second at an angle theta equals 30 gram naught. To the horizontal, from the top of a cliff, of this height. So what's the height of the cliff? H1, that is 50 meters. And it hits the ground at point P. It hits the ground in that projectile. This is point P. So find the maximum height attained above the ground. So maximum height attained above the ground, we use that formula. We equal to what? Gt squared, but we don't have t, we don't have time. So let's use the formula that goes with the parameters we have. Now, there are two formulas that I told us to use that we got. We got this formula and where's the other one? It's not here. So we have to do it this way again. H1 plus H2. What is H1? 50 plus, what is H2? H1 is the height of the mountain. What will H2 be? H2 will be the height of the projectile, which is u squared sine squared theta over 2g. 2g or g? 2g. So H max therefore becomes 50 plus, you see that by solving more and more questions, you become familiar with the formula. So u squared, that is 80 squared times sine 30 all squared over 2 times 10. Never you come to use this to cut this, okay? So that's H max equal to 50 plus 6400. 6400 times sine 30 is 0.5. 0.5 squared, 0.25. That's like 1 over 4, 0.25 over 20. So this takes care of this. We have 640 times 1 over 4. So 50 plus 640, Half of 640, here 1 here is 32. So 320. So we have 320 times 0.25 is 1 over 4. Here 1, here 80. So the answer is H max equal to 50 plus 80. That is 130 meters above the ground. And I think that is the answer. All right, the next one. The time of flight, the total time of flight. Let's just use the formula. Let's check the formula we're going to use already here. Which one we can either use that or this and we'll get the same answer. That's the truth. So, but since this one is closest to us, let's use it. If for this one, we'll just use H max will be this. Is it clear now? And you'll get the same answer. So you can verify that yourself. So I'll just claim this part. Now, what is this H? Oh no, let's use, okay, H is the height of the mountain is given. H is the height of the mountain, this one. Because this formula was gotten from the time taken to go from the height of the mountain down. You remember, right? So this becomes T equal to, that's question 2. T becomes 2 times U. What is U? 80. Sine 30 over 10 plus the square root of 2 times, what is H? Height of the mountain, 50 over 10. This takes care of this, and we have 10 here, square root of 10. So T becomes here, this cancels this. We have 16. 16 times sine 30 is half, plus the square root of, oh, we need not even cancel yet. Oh, it's the same. It's the same because it's 100. Square root of 100 is 10. Square root of 10 is 2. So it's square root of 10 we need here. Square root of 10. So we'll have here 1, here 8. So T becomes 8 plus root 10. What is root 10? That will be 3.16. So T becomes 8 plus 3.16, which is equal to 11.16 seconds. And that's the answer. And the last one, the horizontal range. So with the horizontal range, you can easily use this formula, right? And with the horizontal range, you can just apply the formula we just got here. All the formula be U squared sine 2 theta. I hope you know how I got this formula, please. Make sure you rewind. If you don't understand, you will understand. I promise you. So U squared becomes 80, range becomes U squared, which is 80 squared, times sine 2 theta. Sine of 2 times 30 over G, 10 times plus, U, which is 80 again, times root 2 times H. What is the H here? What is range 2? Is from the height. So this H is the height of the mountain. H max is different from H. So when it's H, it's always height of the mountain for these formulas, for these ones. Is it clear? So H times 50 over 10. So the same way I think it still gives us root 10, right? So 80 root 10, here 1, here 10 cancels, you know this one is 6400, so it gives us 640. R becomes 640, because this is 6400, times sine 60 plus 80 root 10. Alright, let's do that with the calculator. 640 times sine 60. 640 sine 60 is 554.256 plus 80 root 10. 252, that's 80 times 3 point something is 252.98. So let's do 554.256 minus 252. This is like, there's 2 here also. 252.982. That gives us 301.274. So let's use it as 2dp. meters. So that will be the range. So you saw I use all the formulas now. Good. Now let's go to the next question, next type of projectile. Let's now see projectile on an incline. Is someone there? Let's now see projectile on an incline. Then after that, we'll now see how to throw a bomb. Exactly, I'll show you how to throw a bomb because no, just for the sake of for you to prepare. You understand when things just happen. I'll teach you how to launch a bomb and hit the target. Is that clear? All right, let's quickly see projectile on an incline. So far we have been examining projectiles that are thrown from horizontal surface. Okay? So now what if we launch a projectile from an inclined plane? So let's say this is our Cartesian coordinate plane. If we launch a projectile at this angle, for example, along a plane, for example, on a staircase, let's say we are standing on a staircase, we now launch our projectile. So for example, these are our staircase like this. Okay, so we now launch a projectile. So along this plane now, so I'm drawing the straight line on it, is along that plane we now launch our projectile like this. Now, what is going to happen? Now, you know that this our ladder or our staircase is inclined at a particular angle, right? So that angle, let's call that angle alpha. But we launch our projectile relative to the horizontal, we launch it at an angle theta. We launch it at an angle theta. Okay? Now, what will be, since this entire place is theta, what will be the angle along the incline? The angle of our launching along the incline. It will be this angle, this total angle theta minus alpha. So that will be theta minus alpha. Is that clear to you? Not 90 minus theta. 90 minus theta will be this remaining part here. Is that clear? All right. Let me now, I've actually made a video on this before, so maybe I'll refer you to that video. But it's very simple. It's very simple. Just watch. I said we incline at an angle alpha to the horizontal. If I launch with respect, because usually what they will give you, they might not really give you this alpha, or they might not give you theta. But the point is that usually you don't give you this angle relative to the incline. So they might just give you this theta, the angle of inclination, the angle at which the projectile is launched to the horizontal. That's what they might give you. So usually they don't give this one inside there. So you have to know how to calculate it. That's theta, the total angle here, minus the angle of inclination of the inclined plane. So now, so the things now, the properties change now. Many properties change here now. So for example, we'll still resolve this thing. We'll still resolve it to the vertical. But here, well, our vertical will not be just our vertical. Now listen. The vertical component of this thing, you want to resolve now. U sub y will now become, you know, these are y components, these are x components. These are our x components, these are x components. If you want to resolve this angle now to this surface, u sub y becomes what? U, we are opening, right? We are opening up this angle here. Now the u open is sine, right? U sine theta minus alpha. While u sub x, that doesn't change, is u cos, because we'll be closing. We want to resolve this thing now. We want to resolve it to this. Okay. It depends on what you are looking at. Now look at this. If we are looking at look at this place. This opening here where is not to this horizontal. The y-axis to this plane, is going to be here. Is that clear? It's going to make 90 degrees. It has to be around here. Somewhere around here. Is that okay? So that, now, it means, because we look at it now, this is when it makes 90 degrees. Look at it very well. This is when it has made 90 degrees. Exactly. So what is this angle here? Now, if we do the math, actually, we will find that I think I did that in the other video. So we find that this angle is actually the same as this angle here. Is that clear? This angle here is the same as this angle here. So in like manner, if I now want to resolve this to the vertical, this is my new vertical, to this plane. This is the vertical to the plane. So that becomes, I'm opening up this angle, theta minus this. That will look like I'm closing phi plus a small angle here, 90 minus theta here. So the point is, if I'm resolving this, I'm opening it, theta minus phi. Now this one, cos, I'm closing this down here. I'm closing it down here, that will be cos theta minus phi. I hope it is clear. Good. If that's clear, let's now do the things associated, such as time of flight. Now, what is the time of flight in this case? The time of flight is going to be here, right? Along the time taken to go from here to this place. But now watch, the g value also changes. Because if you look at this intuitively, you see that g now is at an angle. Because this plane is at an angle. So g, if you want to resolve the g vector, g should normally be straight down, right? G should normally be straight down. But now it's now at an angle that's opened by an angle which is the same as alpha. Okay? So this component of G here, let me redraw that thing here like this. These are y-axis. This is alpha here. I'm just redrawing this component now. Our G is acting straight down. So the angle that coincides with our G, the G, we want to take G with respect to the plane now. The G with respect to the plane will be the G that is going like this. So this will also be alpha. Opposite angles are equal. Vertically opposite angles are equal. So this component of G will be what? Just take it as we are closing alpha, right? So that will be G cos phi. Is it clear? That component of G will be G cos phi. Alright. So if that's the case, since you already understand that, then we can start doing our thing. Remember that when we wanted to take time of flight, we use this formula that on this place, the h will be 0, or distance travel will be height. You know that h equal to ut plus half gt squared, or minus half gt squared. This is how we should take it. Minus half gt squared. If that's the case here, h will be 0 here, right? So 0 will be equal to, now this u will be which u? It will be uy component, right? From the way we derive time of flight the other time. So, sorry. Yes. Excuse me. Uy component t minus, I think I need water. Let me finish this. Uy component times t minus half. Now, this g is now g cos theta. So g is now what? Has turned to what? G cos theta alpha, sorry. Alpha, because G is not on the horizontal. Our guy is not being projected from the horizontal. G is at an angle now. Okay, so the angle will also affect the value of G. So G what? G cos alpha t squared. You bring this guy here, it becomes half G cos alpha t squared times t squared will be equal to Uy. What is Uy? U sine theta minus alpha. U sine theta minus alpha times t. So t takes care of t, divide both sides by t. So the total, so by the time you take g cos alpha t over 2 is equal to u sine theta minus alpha. Okay? You cross multiply and you have t. This t now is now total time of flight. So let's change it to capital T. Capital T g cos alpha is equal to 2 times this. 2u sine alpha theta minus alpha over, so divide both sides by g cos alpha over g cos alpha. So t therefore becomes 2u sine theta minus alpha over g cos alpha. So what do you notice? Compare it to the former equation. If you compare it to the former equation, What my equation says 2u sine theta over g. You see that it's just this alpha factor that is changing. Do you see that? Let's verify it in other equations too. What will be the maximum height reached? So this maximum height too will be seen with respect to the horizontal, right? So using the formula V, we said V will be 0, that V sub y will be equal to u sub y squared minus 2gh. But this is the formula I want to use. So u will be 0 at maximum height now. V will be 0, right? Rather, v squared will be 0. So since v sub y squared is equal to 0, this one comes there. We have 2g now is g cos phi, right? So g cos phi times h is equal to uy squared. What is uy? Uy is u sine theta minus alpha again, right? So u sine theta minus alpha all squared over, so divide both sides by 2g cos phi, 2g cos phi. Please do what to subscribe to the channel, okay? God bless you. This takes care of this. So what will h be? H from here becomes u squared sine squared alpha, theta minus alpha over 2g cos phi. What do you notice again? The formula, the normal formula for horizontal surface will be u squared sine squared theta over 2g. So you see it's just the cos phi factor and the phi factor here that is changing. Do you understand now? Good. Now let's try to get an expression for range. Let's get an expression for range. I'll clean this. This place should be enough. Let's see. So what would the range be now? Now there are two ranges. The first range is this one here. Okay, and the second range is this one here. So first, let's calculate with respect to this range here. Exactly. This range here. Why? The reason is it will be easy to calculate this range here because this range will be the hypotenuse of the triangle here. Exactly now. So you see that it's a smart idea. So to calculate with respect to this range here, you know that the normal range R is equal to u cos theta times t. That makes sense, right? So, but this time here, what changes? I'm coming. U cos theta. So this time here is going to be the time taking. I'm coming, please. You know that R is the range from here down, right? Okay. Okay. And of course, this thing changes to, a formula becomes R equal to U cos, okay, the formula we got, U squared sine 2 theta over G. Okay, that's the formula for range normally, right? Now, but this range here is going to be, this is the range for horizontal surface, right? This is the range for horizontal surface. Like if I completed this, you understand? Provided I still going in the same parabola, the range here is going to be that. Is that clear? So the range here is going to be the value of the hypotenuse of a triangle here. Is that clear? The hypotenuse of the triangle here. So what does that become? You know that, what is the, you know what we just calculated is this place. What's this place? These are the adjacent, and these are hypotenuse. So which trig function relates them? That is cos theta. Okay, but what is our theta here? Cos, which cos? Cos alpha. Because we're looking at this triangle here. So cos alpha. So cos alpha will be equal to adjacent, which is our R, adjacent over hypotenuse, which is our, let's call that hypotenuse, let's call it our Rx, okay? Rx being that is the range here. Is that okay, this range here? So our normal R is going to be, so how do we get Rx? Rx will be equal to our normal R over cos phi. Is that clear now? Is that clear? Let me look at it with this very well. You know that I'm coming. Let me take water first. So now, one thing I just found out is that this formula is wrong. You know, I said that this T is different now. It's a different T, please. This T is going to be the time of flight, for total time of flight for that guy. You know why we're using the T? Because this point here coincides with this point here for our triangle. So we use the total time of flight, which will be the total time of flight that we calculated just now. So it will be equal to u cos theta times total time of flight, which is 2u sine theta minus alpha, okay, over g cos phi. Okay, so if that's the case, then our formula range changes to u cos theta times this. So that would be 2u squared cos theta sine theta minus alpha all over g cos phi. Is it clear now? So if that's the case, then I now say that cos phi, using the same expression, this triangle cos phi will be what? Adjacent, which is our range, this range, over the hypotenuse, which is the range we are trying to calculate for, which is r sub x. So the range on an inclined plane, r sub x will be equal to, we cross multiply r over cos phi. That's what we did. Okay, it was this one that changed. So r now will be equal to this divided by cos phi. So that will be that will be 2u squared cos theta sine theta minus alpha over cos phi over g cos phi. Now over cos phi is just times 1 over over cos phi just means times 1 over cos phi. So cos phi multiply cos phi, then our range x will be equal to what? 2u squared cos theta sine theta minus alpha over g cos squared alpha. Does this change anything? No. Yes, it does, but you know. So we can now use 2 cos theta. Okay, it doesn't work here. So this becomes our formula. Alright? Alright, so I think, so that's the formula. So which one do we need more? I think that's all we need. We have done range, we've done maximum height. Okay, so that's all. So that's the formula for maximum range. Okay, you know what we'll do? Let me quickly, so let's solve a question. We are not tired, okay? Alright, so this formula says this question rather says we should calculate the time of flight. So time of flight t, recall that the formula is 2u sine theta minus alpha over g cos alpha. So we need theta. Theta is the angle to the horizontal. Let's interpret the question. It says That an object on an inclined plane. So let's say this is our inclined plane. The inclined plane is inclined at angle 30 degrees, right? So this is about 30 degrees here. Okay? So if that be the case, then they now project it at 60 degrees again. I mean, that's like projecting at 90-degree angle already. Do you understand? So that makes sense. This diagram makes sense. So this is 60 granite. Oh no, sorry. So the horizontal is projected at an angle of 60 degrees to the horizontal again. Sorry. That 60 degrees is to this horizontal, please. It's to this horizontal, that's 60 degrees. So it means the angle here is 30 degrees. Our alpha is 30. Our theta minus alpha is 30 degrees. So our theta is 60 granite because it's to the horizontal, and our alpha is 30 granite. No. Yes. That's the angle of inclination of the plane. That's 30 granite. Alpha is the angle of inclination to the horizontal, 30 degrees. Theta is the angle of projection to the horizontal, 60 degrees. So we are good to go. U is now what? Velocity of 80 meters per second. G is 10. So we can go on to saying that T equal to 2 times U, 80 into bracket 80 times sine 60 minus alpha. What's alpha now? 30 over 10 by cos of 30. Alright? So we have T equal to 2 times, that's 160 divided by 10. That is 16. Sine 60 minus 30 is 30. Sine 30, that's half. Cos 30, that's 3 over 2. So T becomes, you just use your calculator. I just want to do something. That becomes 16 times half. That is 8 times 2 over 3. So that becomes 16 over 3. So 16 divided by 3. 9.237. So let's just do 9.2. 9.2 seconds. Or 9.24 seconds. 9.24 seconds. Then the second question says we should use the range. Very simple. Just use this formula. You see, it's very simple to solve. You just have U is this. You already have what you need. So tell me the answer in the comment section to show you, to ascertain that you followed this video up to this point. Now let's do the last part of this video. Okay, we'll do one more thing after this. That's just the energy in the projectile. So that it will mean that this video covered everything you need on projectile. Is that clear? So make sure you are writing, okay? You are writing. So, bombing by a bomber, okay? Bombing, okay? That is launching of bombs, bomb launching from a jet. So that's another type of projectile. Now, if a fighter jet, that day I was in a fighter jet, so, I wanted to launch a missile from here like this. So that my missile would go like this, will look something like this. That time it was a new type of this thing. So this is my fighter jet. It wants to launch to hit a target here. So let's say it's a house, the building that those enemies, the enemies come. You understand? So he wants to hit it now. At what angle of depression must he launch it? At what angle of depression? That is, what is the angle here? That's what he's saying. Now, if it's the angle of depression, then we'll take this plane here like this. That angle of depression will be equal to using this as our horizontal, this is our horizontal here. This angle of depression must be equal to the angle here, theta. We will call this theta. Do you agree with that? Good. So the angle of depression, since this fighter jet is at a height h, and it wants to throw bomb to this guy at a range x away from that point, then we can use this is relative to this angle, you know that I said this angle and this angle are equal, right? Using alternate angles. So using that angle, this will be opposite, this will be adjacent. So tan theta equal to opposite h over adjacent x. Okay? And this x, recall that x is given by ut. And what is t? T is the square root of, I'm coming now. You know that t for this value, remember that for a body coming down like this, h is equal to half gt squared. I've showed you this, that u will be 0 from there. So t will be equal to the square root of 2h divided by g. I've showed you this equation before. So it's because I did not cram it, that's why I'm just deriving it again. So x becomes the square root of 2h over g. Let me do something for you here. See, I can square this. If I square this, x squared, there's a reason why I'm doing that. X squared becomes 2h over g. Right? Let's hold this for now. Let's hold this. Let's hold this. Now, this h here, does it have any expression? Not really. Okay. What can we do? Okay, yes. The reason why I squared is to make my expression easy here. So I can also, because I have x squared here, if I square this side here, I can also square this side here. Makes sense? If I square, I can square both sides. If I square both sides, then here I will have that tan squared theta is equal to h squared over x squared. So and what is x squared? X squared is 2h over g, right? So I can therefore see that tan squared theta becomes, what is h squared now? It's th squared over x squared, which is now 2h over g. Is that clear now? Sorry, 2h over g. So g will go up, from normal math. Tan squared becomes gh squared over 2h. So h cancels 1h, right? Sorry, I made a mistake. See, look here. Let's go back from here. It's very simple. It's just a silly mistake I made. It is t that I will square. I want to square both sides. Or t will become the square root of 2h over g, right? So that x becomes u times the square root of 2h over g here. I discovered that u did not feature in my formula, my new formula. So I can now square both sides here. If I square both sides, I will have this squared is equal to this squared. So I have x squared will be equal to u squared. It's not even better. U squared, then this squared, square cancel square root here. This one u squared times 2h over g here. This is what I was looking for. So we have this as our h squared. So that as our x squared. So that tan squared theta becomes h squared over x squared, which is now u squared times 2h over g. So that becomes tan squared theta becomes h squared over 2u squared h over g. So g can go up. So that tan, you just do your math. I've showed you this before, that when you are dividing by a fraction, this denominator of the fraction will go up. So that becomes h squared g over 2u squared h. This takes care of one of this. So that tan squared theta becomes hg over 2u squared. By the time you take square root of both sides, then tan theta becomes, what we are trying to get is the angle at which you must launch this thing to hit your target. Exactly, that's what we're driving at. So tan theta, because every other thing according to this projectile, this is as former, h as former. Is that okay? So that angle theta must be equal to, tan theta will be equal to the square root of this. Or I can isolate this one out. So the square root of this one, square cancel square root, so that it becomes 1 over u root hg or gh, g comes before h alphabetically, over 2. Is that clear? So that our formula theta therefore becomes the tan inverse of 1 over u root gh over 2. Is this clear? So that is the formula for, so that was what I used to calculate when I launched that bomb. You understand? This is the formula I used. That theta equals the tan inverse of 1 over u root gh over 2. Alright, so that's the formula that I use to calculate my distance for bombing. Now, the last one is the energy stored in a projectile. The energy stored in a projectile. Now, what is the energy stored in a projectile? Energy stored in a projectile. Now, it's very simple. There are two types of energy. We have the potential and the kinetic energy. Now, when the body is moving, if a body is projected, at that maximum height, you might think that it will not have, that since V equals to 0, you might think it might not have kinetic energy. It will still have kinetic energy. But the V now will now be Vx. See, when you project a body, remember that at this point, V is 0. V sub y is the one that is 0. V sub x is still moving because it's still moving. Is that okay? V sub x is still moving. So the kinetic energy at this point, it will have both kinetic and potential energy. Is that okay? So what is the kinetic energy at that point? The kinetic energy at maximum height now. At maximum height, the kinetic energy will be equal to Ke equals half mv squared. Now, which v will this be? V sub x. And what is V sub x? V sub x does not change. It's the same as U sub x. And U sub x, we said, was what? U cos theta. So K sub E, Ke will be equal to, right, 1 over 2 mu, half mv squared, right? So mu squared cos squared theta. So this will be the kinetic energy stored. Of course, potential energy is very simple. It's just mgh, all those things. You understand now? Potential energy at maximum height. P at maximum height. P at h max now will be equal to mg times h max. And what's the formula for maximum height? U squared sine squared theta. So we have mg times u squared sine squared theta over g. This takes care of g. So P will be equal to what? Mu squared sine squared theta. So this is the formula for potential energy. So at any particular time, total energy is conserved. It will be P plus K. Is that clear? So that will be it for this video. Do what to subscribe to the channel. Now, if you need questions, just text me on this WhatsApp number. I'll give you the solutions if you don't know how to solve them. So on the WhatsApp number, this. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. God bless you.